Now, how do we edit the data? So again, let's gonna start from a new df as a copy of the data. So we start back to our original data set. We can use the same syntax that we would use for an array. So we specify the row and the column. The column again can be a string, can be a symbol, or can be at positions, and we specify here the value. We can also use different rows at the same times, but in this case we need to remember to broadcast also the assignment operator. And here we can see that we changed 10 and 11.3 here. We can add new row with push, exactly as this would have been a matrix. So we push to the data frames, and this is the data of the row that we add. We can sort a data frame with sort functions, where we specify the column from which we want to sort, and if we have to sort reversely or not. So here is sorted by country first, and year. So first is the country, and then is the year. Now, sometimes we want to copy not the data itself, but we want to copy the structure of the data frame. So we can use similar to copy the structure, and here we copy also the size of the data frames. The content that we have here is garbage, is not defined, but we can use these nice things also as a trick to empty a data frame, because similar accept a second parameter, that is the row that we want to keep. So here I could have said df similar to, so we have two rows data frames with the same column type as df, and we can use it with 0, and we get df, so we similar to itself, and we assign to itself with 0, and in this case, doing this, we end up with a data frame with empty with 0 row, but with the same structure as the original data frame. So let's now work on. So here we changed the data. So let's now to see how can we change the structure of the data frame. And again, let's gonna go back to our original data set. I can add a column, but simply with this syntax, data frame dot the name of the column that I want to add and the value. They can be an existing column that I replace with this data. I rebind to this new array, or this can be a new column that we add to the data frames, like in this case. And notice that it's very easily to make operations based on existing data. For example, I have a forest volume, I have forest area, I can compute a column called volume per hectare, by simply dividing the volume by the area. Just this bit is important, that we broadcast again, because this is a vector, and this is again a vector, so the division also must be broadcasted. And if I want to add a column that I don't yet know the value, but I know that here in this column Go I will add floats, what I can do is that I can add an empty column, well, empty filled with missing. The important thing is that the missing I need to give this column the type of union missing and the type of the elements that I will want to put. What I want to say is that, okay, let's say that I know that I cannot compute already, but I want to add another column, go, and I know that this go column, then I will fill it with float numbers, but I don't yet have them, so I'm starting with what I would like to have an empty column. I could fill missing a value, but if I fill it with missing value, I will have a column with missing only, and when I will try to put floats, I will get an error because Julia will tell me, hey, you're trying to put floats in a column where the inner type is floats. So I need to use this syntax here to add a column filled with missing, but already accounting for the possibility that inside this column I can also put float values. So this is all to add the columns. What if the opposite? I want to remove columns by name. Well, I select the data frame, specify the column that I do not want to keep, as in this case. And what if I want to rename my column? Well, if I want to rename all the column, I can just use rename and the array of the new names that I want to do. If I want to rename only one or two specific column in a group of many, on a data frame with many columns, I can use instead a dictionary with the old name and the new name that I want to give. If I want to change the order of the column, again, I'm just reselecting, nothing else than selecting my data frame. I mean, put attention, in this case, I'm using the column operator, but would be the same with the exclamation point. And I'm putting here the array ordered in the way I want. So here I'm just changing the order of the column with year, country, for area, and for volume. And finally, if I want to insert a column, I can use insert calls where I specify the data frame, the position, and I give the new column that I want to add. What if I want to change from integer column and transform it in a string, or the opposite, a column that I have value as a string, I want get back them to an integer? Well, I'm writing here these two method here, but really these are not specific to data frames. These apply the same to an array. So because the nice things of data frames columns, again, I repeat it again, is that the columns are just arrays. So here I just can use a map to broadcast the function string to each element of here, and I call the resulting vector, that will be a vector of strings. So it will be like string 2000, string 2020, and so on, in a new column that I call it named year. And here I do the same with parse. The only things here that I'm doing in particular is that I put all my parse function within a try catch block, so that if the parsing doesn't happens, I don't have an error, but I catch the error and I return missing instead. So here, if I would have some elements that cannot be parsed as integer, I already have them as missing. So here is how we can add change columns, and how do we work with between data frames. Here I can concatenate horizontally, so column by column with hcat, the same as I can do for arrays. The things here is that differently from arrays, here we have names. So as here I'm using basically the same df and data are the same name. I use this make unique to automatically change the name, because we cannot have in a data frame the same name. Of course, we cannot have a for area and for area. So here automatically the name are changed with adding this country is it adds this one suffix. So let me go in to copy the data, and here is how I concatenate the data vertically, basically adding new rows. So of course, when I concatenate the data vertically, I need to have the same column name. Actually, I'm not 100% sure. Let me try it. df equal copy data, and df copy data again, df2. Okay, so these are the same. So of course I can say vcat df and df2, and this shouldn't give me any problem. But what if I change the name? So I rename df2, and I rename country as country 2. And let me see if this is still valid. Now, can you see I have an arrow? So actually, it give the it is nice vcat, because it go to concatenate the single column. So it lets me rename, go back country, and lets me swap. So let me change the column order. So df2 equal df, the one I just put it in front, df, and let me change the column name. And so I just can copy and paste these things here. So, and I put a different order here: country, forest area, and forest volume. Okay, df2. Okay. So what happened where I am? I must have forgot some yeah, here I put one more. Okay, let me see now if I got it. Should go. Yeah, it's very great, nice, because so vcat doesn't care about the positions, but look for the column names and do and concatenate vertically the right column given by the name. So it doesn't work by position, but by the name of the column. Nice. And the way to implement categorical data in Julia is using the categorical arrays, or also the pooled arrays package is another package, but here we're using categorical arrays. And we replace the column using the keyword categorical, the function categorical. And you can see if I type df now, I see here that the type has changed for here in a categorical. It's no longer an integer. And if we want to transform all strings column to categorical, or we can use a loop over all columns and look for abstract strings inner type, as we did before, or we can use the transform functions and use this syntax here with the data frames. The names of the data frame with are which columns are abstract strings, and transform it in with the categorical functions, and we do not rename the column. And here we obtain a data frame where all the strings are, in this case only country anyhow, are become categorical. Oh yes, also named here is a string. So with categorical data, we use much less memory. If the same data is repeated several times, the same, for example, a country, and grouping also is way more efficient. Although by my experience, filtering is not necessarily quicker. When you have a categorical data, we can extract what are called the levels, that are the individual unique elements. So here will be 2000, 2020, or here the country will be the 4 countries. What also is very useful categorical data is not only to compress the data and to get more efficient grouping, but also that allow personalized order. So we can here define the order of my categorical data. You can see here that this is not alphabetical order, not reverse alphabetical order, it's just personalized order. But when I put my levels, when I apply sort, it will sort by the way I defined my levels, and it's very nice because at this point, when I print it, it will use the order that I, in theory, yes, of course, because here is not the place. This is here. This is the one sorted. So here is the array sorted on the order that I specified. If I want to sort the data frame itself, I need to use the version sort df and country, and here my data frame is sorted the way I specified here. Finally, sometimes you want to convert a categorical array into a normal one, and you can, to do that, you can use the unwrap function with as unwrap take the value you need to broadcast over all the rows, and here you have the value back as a vector of integer. Sometimes you want to join data frames, so let's gonna create 2 identical data frames, df1 and df2, just for the objective to join them. And let's gonna add some different data, some different rows on df1. We add the US, this is dummy data, and this is China. And let's go also to rename the column here of 2 lower letter here for df2, and we can join data frames by specifying so here we specify the data frames that we want to join, and with the keyword on we specify the column that we want to use as joining key, and if the country if the column has the same name in both the data frames, we just put the name. Otherwise, we can make a pair with the name on the left data frames with the equivalent name on the right data frames. And finally, as many column names here are the same, so they have the same name, again we need to use make unique equal to true in order to get only to get the different names for the other column. Otherwise we will have an error. And let me assign it so we can print it well, and I can print it here. So here we have a country, and here that are the common column, and then we have for area and for volume from the DF, and then we have for area and for volume with this suffix that come from the F2. So these two columns come from this data frame, and these two columns come from these data frames. You see here that as the F1 had US and the F2 has China, the default sorry, here is an inner join specifically, but it would have been the same with a join, because the join by default, no, it no longer exists. Sorry, this was the old, before it was join, now they changed the API. So before we had a function join that was defaulting to inner join, and now we need to specify explicitly that we want an inner join. But this is, we just join the records that are common from the two sides, but other type of joins are available. But is it the left join? If here I put the left join, I will have only all the record that are present on the left side. So here we will have a US, but we will not have China. So we in place of the second data frame, here we have missing. Say opposite things if I use join, if I have right join. Outer join will return all the records, so we return US and China. Semi-join is like inner joins, but we will only have the column of the first data frame. And anti-join, I will have only those that are not present in both the data frames, so we will have only US and China. And finally, with cross-join, I have the Cartesian product. So for each Germany, here I will have all the other countries. So I will have it repeated 8 times Germany, 8 times France, and so on. The Cartesian product of all the records of the first data frame with all the records of the second data frames. Okay,